Okay, great. So let's move on. So now I have read it in as CSV. Is everybody ready to go from at that point?
Yes.
Okay, great. So we're going to be, the first thing we're going to be running is a Poisson regression. And like you heard in class, we use it when the dependent variable or our outcome variable is a count variable or a rate. So it's just a log of the mean. And so because it's a log of the mean, once you take the log, it's almost like linear regression. So sometimes it's also called the log linear model. So the example that we have here is that we want to determine whether the mean number of call duty days differs by gender among resident doctors, right? So before we go on, as you've heard over the last few weeks, it's always a good practice to look at your data set, just, eyeball it and see what's in there. So to do that, I'm going to just use the add command. So add RDS just to show me the top six or more, the top six observations. So you can see here that what I get when I use the add RDS command is I get a table that has 6 columns, the first 6 observations, six rows, the first 6 observations, and you can see that it has 17 columns. So there's 17 variables. You can see age, mental health score, job satisfaction, the age, category. So you can see all the information that we have in the data in the data set that we will use. This is just good practice. Is everybody at this point?
Yes.
Yes. Okay, thank you, Abbas. Thank
Hello.
you. Hello?
Hello. Yeah, please, I use this command view RDS so that it will display on my on the upper part of my screen. Then I noticed that it was adding like the job satisfaction score was adding 9.00, which wasn't in the Excel format. I don't know, is it okay? But on the head RDS, we just run, everything was just perfect without the decimal point that was included in the view RDS I did earlier.
Okay, 1 minute. I'm just going to view it and see. Where is it now?
Yeah, just like what is under mental score, 24.00, like that. So is that okay?
No, yeah, that's fine. That's fine. It's just you can see it's 0.000, so it's like,
yes,
they're still whole numbers, right?
Yes, they are.
Yeah. Okay, so I'm going to close this. Okay, great. So now let's go on and fit our model. So for this, we use the GLM command. So fish.m1 is the name of the object, and we can choose any name we want, right? We're using the GLM command, and our outcome variable is the calls. Our predictor variable here is female, which is the way that the gender was documented in the data set. So it's female 1 or 0. Then we specify to R and say, this is the name of my data set. And then we tell R in the GLM command, I want you to, the family of regression that I'm doing is Poisson, and my link is log. Remember that we said this is a log of the mean. And once we write that out, we ask R to run it and to also summarize it. So this is what we have here. So once you do that, you then see R tells you, R gives you this output that tells you, okay, this is what you called for, and this is what we get. So remember that the mathematical notation for Poisson regression, it is a log of the mean, and it's difficult to interpret. how do you write in your result, or how do you communicate to the people that you're trying to share your result with that the log of the mean number of call days is negative 0.8, right? They're going to look at you like, okay, what does that mean in real life? And so to make the result interpretable, we take the exponent of our coefficient. So the exponent of our coefficient, and then we also take the exponent. We also ask R to take the exponent of a confidence interval. So here we are. I'm not going to type this out because I don't want to. So here we are. This is what we have. Is everybody at this point? Please let me know when you get to this point. Okay, great. So is everybody at this point where you have the regression outputs?
Yes.
Okay. In addition to Abbas, Omotoye, Osiama,
Yes.
how are we doing?
Yes, yes.
Okay, great. Okay, great. Thank you. So this is our output. Does anybody want to share with me how they will interpret this output?
Hello, can I try?
Go on.
Okay. Based on the output, we'll now say that the mean number of calls dual residency for female is 55. Is 45 minus 100. Yeah, 55% less among females when you compare them to their male colleagues.
That's interesting.
Thank
you.
The p-value based on that is 0.2 raised power exponent times 10 raised power minus 60, less than 0.01.
Exactly, I would say less than 0.001. So you made a point and said, so the number of call hours by females is 55% less. How did you go from the output of our regression to that conclusion?
Yes, to mostly when looking at the log odds, when you look at it for the 0.44, so when it is less than 1, sorry, the exponent, when it is less than 1, then you minus from 1, while when it is greater than 1, you now translate it as it is. Like if it were like say 1.44, it will be like 1.44 times, when more likely, while when it is less than 1, you now say less. So I minus it from 1 to arrive at, I minus 0.45 from 1 to arrive at 55%. Okay, great. So basically what is, you're correct, Abbas, thank you. So the females have 0.45, the chances or the number of calls, the mean number of calls among females is 0.45% less, or 0.45% of the one amongst the male. So we're basically saying that they take 0.45% times the calls. So it's 1 minus 0.45, which is 0.55, and which when we multiply by 100 is 55. So the females were doing 55% calls less than 55% less calls than the men. Okay, thank you, Abbas. Is everybody at this point? Can we move on? Please tell me if I'm pronouncing your name correctly. Nolu.
You can call me Nolu.
Nolu, okay. Nolu,
thank you.
Are you with us?
Yes, I am following now. Thank you very much.
Okay, great. So let's move on to the next to the next thing. So this is the interpretation that we have here. We infer that, like Abbas correctly said, mean number of calls during the residency was 55% less. And the two-sided p-value was less than 0.001. So we reject the null hypothesis and conclude that the females had fewer calls than their male counterparts.